Hey guys, welcome back, and today we're going to be getting into 4.2, which is solving systems of equations graphically. And for the think/warm-up, I have what does it mean when we solve 11x plus 4? Now I'm not actually going to go through solving this, even though it won't take that long. I'm just asking what it means. Now, when I tell you to solve this, usually we find a value for x, right? We'll say x equals whatever it is. In this case, it's going to be 3. Right? If you ended up solving that. You say x is 3. That's how we solve it. So now my question is, could we solve 3y plus 2 equals 6x minus 13? And your initial answer might be like, yeah, maybe you're used to, I don't know, let's subtract 2 over, and then we have 3y equals 6x minus 15, negative 13 minus 2, and then divide everything by 3, right? Then we get y equals 2x minus 5. But that's not really solved, right? It's not solved for the variables. We solved it for y, right? We have y alone, but we don't have numbers for y and x like we do here. We have x equals 3. X is the number 3. Here we have no idea what y or x is, right? They could be a multitude of things, which is why we this is a line, right? We would graph a line because that would be all the potential solutions of x and y. So a system of equations is when there are just two or more equations put together. So we could solve 11x plus 4 equals 37 because there was one variable with one equation. But notice we couldn't solve the other equation because we had two variables but only one equation. So in order to solve something like that, we would need another equation or a system of equations, right? Two variables are going to need two equations, three variables are going to need three equations, and so on. So here's an example of a system of equations. It's literally just two different equations put together. So to solve a system of equations, you need to find what all the variables equal to satisfy all of the equations. We're going to focus on just two equations in a system of equations, so we need to find the x value and the y value. So for example, these two equations here have the solutions x equals negative 3 and y equals 5, since those are the only two values put together that satisfy each equation. They satisfy both of them, right? If we plug in x equals negative 3 and y equals 5, then we get 5 equals negative 3 plus 8. Well, negative 3 plus 8 is 5, so we get 5 equals 5. That one works out, right? And if we plug in x equals negative 3, we're going to get negative 3 times negative 3, which is positive 9, minus 4, which is positive 5, which, as we see here, if y is 5, we're going to get 5 equals 5 once again. And so these are the only two numbers, right, or one number for each of these that work to satisfy both of these. And so we can express this as a point because they need to be together, right? We need x equals negative 3 and y equals 5. That's the only thing that works. So we can express our answer as a point, negative 3, 5, because a point is an x value and then a y value. So looking at the graph of the two equations that we just looked at, what do we notice here, right? So here's the graph y equals negative 3x minus 4, negative slope. Here's the graph y equals x plus 8, right? What do we notice? Well, look at the solution here, negative 3, 5. Look at this point right here, this point of intersection. Isn't this point right here, negative 1, 2, 3, 1, 2, 3, 4, 5? Isn't this point negative 3, 5? And that kind of makes sense, right? Here's all the points on this line, and here's all the points on this line. So the one point that satisfies both of the lines, that's on both of the lines, is where they intersect. So one of our methods to solve a system of equations is going to be to graph both of the lines, right? And then find out where they intersect. So for our first example here, y equals negative x minus 2 is our first line we can graph, where at minus 2 is the y-intercept, and then negative x just means up 1 over 1, but in the negative direction. Right? And we can keep going on and on and on. And I'm going to use a line here and try and do my best. Okay, so there's line 1. And then normally we'd have arrows at the end, but I'm just using Smart Notebook. And then the other one here, 1/3 x minus 6. Minus 6 is our negative 2, 4, 6. That's our y-intercept. And then a slope of 1/3. Remember, rise over run or y over x is how this goes. So up 1 to the right, 1, 2, 3. Looks like we've already found our solution. Up 1 to the right, 1, 2, 3. And then if we graph that line, we'll notice that their point of intersection is here. And we can just count 1, 2, 3, x equals 3, and y is negative 1, 2, 3, 4, 5. So our answer is 3, negative 5, because that's our x value and then our y value. X value of 1, 2, 3, y value of negative 1, 2, 3, 4, 5, where they intersect. Here, same thing. I'm going to graph this one first. We have negative 4 is our y-intercept. 1, 2, 3, 4. And then we have a slope of negative 3/2. Rise over run means we go up 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. Then we can go over 1, 2 and down 1, 2, 3. And we can do our best to graph this line. It's a little off. I'm going to do this and then move it. That should be good enough. We'll be able to tell. And then our other line here, x plus 1, that's a pretty simple one. We start at 1, and then the slope is just x. And it looks like that'll be our solution right there. But if we were to graph it, it would look like that. Right. And then the intersection would be our solution, and they intersect at this point right here. And that point is negative 1, 2 for the x, so negative 2, and negative 1 for the y. Both of these satisfy these equations, right? And if you ever wanted to check, you could plug negative 2 in for x and negative 1 in for y for each of these and make sure that they work. So same thing for this one. Let's just keep going. Y equals 2x plus 1, so plus 1, and then 2x, we're going to have a slope of 2, right? There's a slope of 2, and I'm going to do my best to draw a line here. That looks pretty good, actually. I'm not going to worry too much about it. Now, here is something that we will have to work with. We can't graph this right away, right? So let's solve for this. The first thing, I'm just going to solve for y for these so I can graph it, right? So I'm going to subtract x from both sides. That way these x's go away, and I'm left with negative 3y equals negative x plus 2. Then I'm going to divide everything by negative 3. All right, so then we're left with y equals negative divided by negative is positive, and x divided by 3, we can write that as 1/3 x minus 2/3. Okay, here's one more problem, right? I don't know if I really want to guess negative 2/3 as my point. So what can I do, right? Instead of guessing where 2/3 is and graphing from there, I can just plug in some points, right? So let's do that and see if we can figure something out. You know, thinking ahead, maybe I could plug in. Well, actually, if x is 2/3, that's actually not going to be that big of a deal. X equals negative 2/3. We know that that's 2/3 of the way down there. And then 1/3 x means up 1 over 1, 2, 3. So it'll be like 1/3 of the way there. If not, you can try plugging in points to see what 2 points you can get. All right, we can do our best to graph that. And then I think we could see here where a point is supposed to cross. Right here at -1, -1. So that would be our answer. Last example here. We have y equals 2x plus 1. That's the same one we just had. We're up at 1 and then a slope of 2. And I will do my best to get that line. I did a pretty good job on that one. And then here we have to solve again, so let's subtract 6x from both sides. Get -3y equals -6x plus 9. Divide everything by -3 once again. Then we're going to get y equals 2x, -6 divided by -3, minus 3. Alright, so maybe I should have done that in blue. But we'll graph this one now. We're down at -1, 2, 3, and our slope is 2. Okay, and 2. And then we can graph this one to the best of our ability. And what do we notice here? Right? These never cross. So because they have the same slope, right? Same slope, different intercepts, they never cross, which means there's going to be, if there's no point that intersects, and that means there's no solution, right? And if it just so happened that they ended up being the same line, right? We had a system of equations where both ended up being the same line, then there would be infinitely many solutions, right? Because they would be touching at all of these points. But in this case, where they are not touching, it is just no solution. And that is going to wrap up 4.2.